the product rule. I'll tell you one thing, like in differentiation was p into d by dx of q plus q into d by dx of p, there is no direct formula, there is no direct product rule. So if you are given x minus 1 into x plus 2 dx, there is no product rule in integration as such. So what we'll do is we'll multiply and we'll simplify this. This is x squared plus 2x minus x minus 2 dx. So this is x squared plus x minus 2 dx, and this is integration of x squared plus integration of x minus integration of 2 dx dx dx. So this is x cubed by 3, this is x squared by 2, and this is 2 comes out, integration of dx is x plus c. If the question is again having let me say on x plus 3, then you multiply all this, get a figure like this, and then individually integrate like this. So how is the product rule in integration of then? So integration of u into v dx is u into integration of v minus integration of v into differentiation of u for this integration sign, there is a dx. Like in differentiation, there was dy dx of p into q. P could be anything, q could be anything. There is a minor change here, that u and v will be governed by eyelet rule. Which will be u, which will be v, will be governed by eyelet. What's eyelet? Is I is inverse, L is logarithmic, A is algebraic, T is trigonometric, E is exponential. So inverse looks like sin inverse x, cos inverse x, logarithmic is log of anything, algebraic is anything involving x square, whatever it is. It could be x plus 1, could be root of x plus 1, and so on. Trigonometric is sin x, cos x, tan x. Exponential is e to the power x. So first we'll have to see whether, let me say, we'll do a problem right now. This is x into e to the power x dx. Now is it in the form of eyelet or not? So x is algebraic, e to the power x is exponential. Yes, it's coming in the eyelet, so I can take this as u, this as v. Had it been like this, e to the power x dx, e to the power x into x dx, I can't take this as u, this as v. I'll have to change the question into the eyelet form. This will be x into e to the power x dx. Then only I will use the product rule. So how will I use this? Integration of x into e to the power x dx. The formula looks really difficult, but it's easy. So what I'll do is x into integration of e to the power x minus integration of e to the power, integration of e to the power x into differentiation of x. So this is x into e to the power x minus, you can easily make out this quantity is same as that of this quantity. So this quantity will come here. D by dx of x is 1. So this is x e to the power x minus integration of e to the power x dx. E to the power x into 1 is e to the power x. So this is x into e to the power x minus e to the power x plus c. E to the power x you can take common. This is x minus 1 plus c. So just get this integration and just paste it like that, and finally this one's answer only comes over here. This is nowhere difficult, but it looks difficult. Let's do one more sum. Let me say integrate x cos x dx. Take whether it is coming in the islet or not. A is algebraic, so x is a, t, so this is coming in the form I can move. So this is x into integration of cos x minus this quantity again over here, integration of cos x into differentiation of x. Dx quantity shouldn't trouble you. For every integration sign, just write a dx. So this is x, integration of cos x is sin x. You can make out that I do not do simply anything for this, but just I'm writing as a formula. So this is sin x into dy dx of x is 1 dx. So this is x sin x minus integration of sin x into 1 is sin x dx. So this is x sin x minus integration of sin x is minus cos x plus c. So this comes to be x sin x minus into minus is plus cos x plus c. So let's do another one. X log 2x. Islet A T E ILAT. You can make out that L should come first, logarithmic should come first, then algebraic. So this is not U, this is not V. I'll have to choose. First I'll have to make log 2x into x dx. So now it is coming. L is logarithmic, then it's A. So this is log 2x into integration of x minus integration of x into differentiation of log 2x dx. So this is log 2x into x square by 2 minus what I got here is x square by 2. dy dx of log 2x is 1 by 2x into 2. dy dx of log 2x I shouldn't tell, but for your convenience I'm just touching, because you should be good at differentiation. Dy dx of log 2x is the star form. Please take your time, or else go with the discussion on differentiation. So this 2 and this 2 is gone, this is gone, so I'm left with log 2x into x square by 2 minus integration of x by 2 dx. Conventionally this is written in the beginning, x square by 2 into log 2x. Trust me, this x and x square are not related because log is the security guard. Minus 1 by 2 into integration of x dx. That's equal to all this remaining the same. Minus 1 by 2 integration of x is x square by 2 plus c. I'll just see again. So this log 2x, x log 2x into minus integration of x. This is 1 by log 2x into 2. This is x square by 2. Yeah, this is x by 2. Hopefully I'm 100% correct.